Hi everyone, today we're going to talk about the atmosphere. So take a look at this picture. This is a view of Earth from outer space. Do you notice the different layers that the atmosphere forms? We can see the upper atmosphere, there's the stratosphere, troposphere, and so on. So when you look at Earth from outer space, there's definitely some layers that you can see in the atmosphere, and that's exactly what we're going to be talking about today, the different layers of the atmosphere. So what is the atmosphere? The atmosphere is all the gases surrounding the Earth. And the gases surrounding the Earth actually have many layers, as you can see here. So make sure you have your note packet out and make sure you're on this page. Let's talk about how the Earth's early atmosphere formed. When Earth was forming around 4.6 billion years ago, it was a mixture of gases and solids, but there was no atmosphere. So the Earth was really, really hot. But eventually, the Earth started to cool down. And as the Earth started to cool down, an atmosphere started forming, mainly from gases coming out of volcanoes, as you can see here. So one vocabulary word that you need to remember is outgassing. Outgassing is the release of gas that was dissolved, trapped, frozen, or absorbed in some material. In this case, gases like these were trapped inside the Earth and they started spewing out of volcanoes to form the Earth's atmosphere. So, if you were asked, how did the Earth's early atmosphere form? You would say the early atmosphere formed from volcanic outgassing, or the release of gas from the interior of the Earth, such as carbon dioxide, methane, and so on. So go ahead and try number one. Scientists have inferred the Earth's original atmosphere was formed by. Pause this video, try this. All right, so next we're going to talk about the structure of our atmosphere. So make sure you have your reference table out and go to page 14. On page 14 of your reference table, you're going to see a very complex graph, but it's pretty easy once you get to understand the different parts of it. So notice that the title of this graph is Selected Properties of the Earth's Atmosphere. So we're looking at the properties of the Earth's atmosphere. And notice that there are one, two, three, four layers of the atmosphere shown in this um, diagram, right? So the four layers of the atmosphere actually end with the term sphere. That's how you know these are the layers. So we have troposphere, stratosphere, mesosphere, and thermosphere. These are the four layers of the atmosphere. They're also called temperature zones because they have different temperatures. Next, you're going to notice that there are some boundaries between the different layers of the atmosphere, and the boundaries between the layers end with the word pause. So, the boundary between stratosphere and troposphere is called tropopause. Stratopause is between mesosphere and stratosphere, and mesopause is between mesosphere and thermosphere. So, boundaries end with pause, and layers or temperature zones end with sphere. You're going to find altitude here, and we have two units for altitude, kilometers and miles. We also have sea level right here at 0. So how do you know how much each interval is going by in kilometers and miles? Well, you should use this equation right here. You can pause this video and write this equation down in your notes if you need to. But what you really should do with any scale, if you want to figure out how much each little increment is going up or down by, you're always gonna start from pick two numbers, okay? And in this case, I'm picking for kilometers 0 and 40, the two numbers that are given to me. You're gonna subtract the bigger number 40 minus the smaller number 0 and divided by the number of jumps between the numbers. For instance, if I want to find how much the increments of kilometers are going up by, I'm going to pick any two numbers that are given to me. I'll take the bigger number 40 minus 0, the smaller number, and divided by however many jumps I have to take to get from 0 to 40. So in this case, when I'm jumping, I'm going from one increment to the next. So 1, 2, 3, 4. 4 jumps between 0 and 4. So I'm going to divide that by 4, and that gives me 10 kilometers. This just means that every increment is going up by 10 for the kilometer scale. For instance, this is 0, 10, 20, 30, 40, 50, 60, 70, 80, and so on. Now, if I want to find the increment for miles, how much is each going up by in the mile scale, I'm going to do the same thing. I'm going to pick two numbers. In this case, I'm picking 25 and 0. I'm going to do the bigger number minus small number, 25 minus 0, divided by the number of jumps. So 1, 2, 3, 4. 5 jumps from 0 to 25. So I'm going to divide that by 5. That gives me 5 miles, meaning each increment is going up by 5. So this would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. So this is a method you can use to figure out how the increments of any scale that is given to you. Now let's look at our x-axis. Our x-axis is a bit strange. Notice that we have three x-axes for one graph. So we have one y-axis and three x-axes. You would read this like any other graph. So if I'm just looking for temperature, I'm going to forget about pressure and concentration and just look at the temperature as my x-axis and altitude as my y-axis. If I'm just looking at pressure, I'm just going to look at pressure for my x-axis and altitude for my y-axis. Same with water vapor concentration. If I just want to find a value for water vapor, I'm going to use this scale as my x-axis and the altitude as my y-axis and so on. So you're individually looking at each graph even though they're all the same graph with the same y-axis, which is altitude. Next, you're going to look at temperature. You'll find that the temperatures are given to you for where the troposphere starts and ends, where the stratosphere starts and ends, where the mesosphere starts and ends, and so on. Notice that 0 is in the middle. My temperature is going down towards the left and is going up towards the right. So the beginning of the stratosphere is 15 degrees Celsius. The stratosphere ends as we go up high by the troposphere. As we go up high towards the tropopause, the troposphere, is getting cooler, right? It's going from 15 degrees to negative 55 degrees. And notice that for the stratosphere, as I'm going up in altitude from the stratosphere, my stratosphere is going from negative 55 degrees Celsius to 0. So that means my temperature is actually increasing in the stratosphere and so on. In the mesosphere, my temperature goes from 0 all the way to negative 90 as I'm going up in altitude. So my mesosphere's temperature is decreasing. My thermosphere starts at negative 90, and as I'm going up in altitude, notice that it's going to around 100 degrees Celsius. So my thermosphere is actually increasing in temperature. Next, we can talk about pressure. If you want to figure out how much the increments are for pressure, once again, bigger number minus smaller number. In this case, I picked 1 minus 0 divided by the number of jumps, 1, 2, 3, 4, and that gives me 0.25. So if this would be 0, 0.25, 0.5, 0.75, and 1 atmosphere. If I want to know the increments for the water vapor, same stuff. I'm going to pick two numbers, in this case 20 and 0. I'm going to do 20 minus 0 divided by 2 jumps between those two numbers, and that gives me 10 grams per meter cube. That means each increment is 10. So this is 0, 10, 20, 30, 40, and so on. So in the next video, we're going to talk about the troposphere.